All right, I am recording. All right, so don't forget, y'all can ask me questions. Stop me at any time. Our group is small, so you got that privilege, and so that I can really go ahead and emphasize certain things. Now, you already gone over chapter 4, right? Let's do some review before I go into chapter 5 over chapter 4. Let me ask y'all some questions. What is a variable? And it's just two of y'all.
I think that variable is a container that holds the information.
Yep, it holds a value. Now remember, there's the difference. What's the difference between an expression and a value when it comes to variables?
Are values specific data types where expressions can have multiple data types?
Pretty much that is correct. Let me write it down. Here we go. Let's use the, yeah, so over here, a variable, see my screen, right? We call it var, right? Now, a variable has a name. So we use the keyword let, right? Let me, I don't want to, let me erase that because it's not a capital, wrong thing. It's not a capital L. It is a lowercase l. So we have every variable with the keyword let or var or const, right?
Mm-hmm.
So a variable, if I say declare a variable, what does that mean? What's the syntax for declaring a variable?
To name it.
Like name?
To name it. And add a semicolon to the end.
There you go. That is right there is what we call declaring a variable. Now, what does it mean to declare a variable and initialize a variable? What do I need to do to initialize this variable?
Would initialize be the same as assign value?
Yep, we need to assign a value. And what's the syntax for it?
The assignment operator. Add assignment operator.
And then we add some type of what? Data type, right?
Mm-hmm.
All right, so if I'm gonna say name, that's descriptive, right? So I'm gonna give it, I'm gonna give it a string. And how do I know a string? How do you know when you have a string?
The quotation.
Right. So right here, I have a string right there. And it's my name, Terrence. Now, that's declaring and initializing a variable. Now, Terrence right here is a value. Everything to the right of the assignment operator is the value. Everything to the left of the assignment operator is the variable, right?
Right.
So an expression is two or more data types. So for instance, if I had this variable right here, I'm going to create let number, I say nums, right? What I'm going to assign to is this expression. 5 plus 5. What's the answer to 5 plus 5?
10.
10?
Mm.
That's the value right there. That's what gets stored in this variable right here. The 5 plus 5 does not get stored in the variable. The value of 5 plus 5 gets stored in the variable. So expressions equate to a value. All right, this is very high level, right?
Mhm.
But it's one of the things that we want to continue to go over to get our heads wrapped around it. So that's why I want to make sure we kind of do a little bit as we go through. We do a little bit of what I call review, and we're going to be doing some review as we go through these chapters, chapter 5. And so what we're going to do, this is what we need to expect. We're going to go through and get as much as we can done within the time frame for the chapter. But on Saturday, for those that can make it on Saturday, that's when we go over the studio. This down here, this 5.7. So today, for this week, take your time and get through chapter 5.
Okay.
And chapter 5, and then on Saturday, we'll go over the studio.
Okay.
Now, we move at your pace. You may get, after a while, once you start getting that passion for this, then next thing you know, you got a routine. You just enjoy going through this curriculum. Pretty soon, you may go further on. That's good. You can ask me questions. Because if you're getting into programming to better your life, get a job in doing this, it's up to you how fast you go. You can get done with this 3 months. It depends on how bad you want it. You can do it sooner than that. But the whole thing is get through, understand JavaScript. And then I can start teaching you about a library like React. I start teaching you React, because that's what's going to get you a job, knowing a frame or knowing something like React, a library like React. That's going to get you a job. And then we'll learn Java as well. And you continue your learning. And even after you get the job, you come back and help us get other people ready to find a job. Because what we're going to do eventually, I'll start giving y'all interview questions. Once y'all understand this stuff, we start building our projects, then I'll give you interview questions to get you ready to interview, get you ready to get a job. Okay? So let us hop back. 5.1, Booleans. All right, what is a Boolean? Without reading that, anybody can you tell me what a Boolean is?
I always think of it as either true, false statements.
That's exactly what it is. Just true or false. And it says here, one of the core features of any programming language is the ability to conditionally execute a segment of code. This is key right here. Ability to conditionally. Remember this word. When you see the word conditionally, I want you to start thinking of an if statement. I want you to say, when I say I need a condition, you think of an if statement. Like if something is equal to something. You see what I'm saying? So remember some of these key words, because as you go farther along in your career, these key words is going to help you to solve puzzles or help you understand how to solve the issue or whatever it is you're trying to solve. So this is a key word to remember. You're going to hear many more words. They're just little bit of information that's going to help you understand how to solve the problem. And it says to execute a segment of code. This means that a program will run a segment of code only, hear that, see that right there, if, so think conditional, right? a given condition is met. And we're going to learn about those later. Now, consider a banking application that can remind you when a bill is due. The application will notify you that a bill is due soon, but only if the bill has not already been paid. The condition for the above example is send a notification of an upcoming bill only if the statement the bill is unpaid is true. Okay, that makes sense?
Yes.
In order to state something like this in JavaScript, we need to understand how programming languages represent true and false. This is the Booleans. Boolean values. JavaScript data type for storing true and false values is Booleans, named after the British mathematician George Boole. I actually have books on him. He's a fascinating individual, born in the early 19th century, which he was born in 1840 something. And he is the one who came up with Boolean algebra. He believed that it's either true or false. As a matter of fact, if you go and find out about his story, he was a believer. And he wanted to prove through mathematics that God was real. And he actually understood that Jesus and God are one by understanding the scriptures. So if you look at his story, it's a fascinating story that, wow, he's considered to be the father of modern day computers. And the computer wasn't even invented until the 20th century. Now here, there are only two Boolean values, true and false. JavaScript is case sensitive. So the capital letter true and the capital letter false are not valid Boolean values. It has to be lowercase true and false. Here's an example. We got a console log true, console log type of true, and console log type of false. Now, yeah, remember what type of does, right?
Yeah, it identifies the data type. Oh,
Yep.
sorry.
Yep, that's what it does. It identifies the data type. Now, the values true and false are not strings. Remember, they're not strings, so they don't get quotes. Only strings get quotes. If you use quotes to surround Booleans true and false, those values become strings. So think like the compiler. When you think like the compiler, when you see that variable and you see that assignment operator, you notice that the value that it's trying to have is either going to be an expression or a value. It's either going to be a string. It's either going to be a number. Now, let me ask you this real quick before I recite some more. What are the 7 primitive data types? Anybody can recite them?
I remember how we reviewed them. I think they were string, number,
2,
Booleans,
3,
nulls, although I don't know them, unidentified, symbol.
undefined, not unidentified.
Oh, sorry, undefined. Sorry.
Yeah, that's okay.
Is the other one integers or?
Big int.
Okay.
That's 6. One more.
Oh. Sorry, symbols?
Yep, that's it.
Okay.
That is it. And now, remember, everything in JavaScript is an object except for everything in JavaScript is an object except for
the 7 primitive data types.
That's right. And why? Why?
Because they're immutable.
There you go. That's one.
And they don't have methods or properties.
There you go. You got it. They don't have methods or properties. And we understand that when we deal with objects. So think like the compiler. Understand these principles, understand these rules. This is going to help you in the future. So here we got a console.log type of true, and then console.log type of true in strings, in quotes rather. So we know the type of true is a Boolean. The type of true that's inside of quotes is a string. So here, Boolean's conversion. Now it says, as with the number and string data types, the Boolean types also has a conversion function. Boolean, notice with a capital B. It works similarly to the number and the string function. Remember, these are called conversion functions. Can anybody tell me why we call those conversion functions? The reason why we call them conversion functions is in the name, conversion. They convert. You use a string to convert something to a string. You may need to do that in your program. You may need to make sure whatever, if it's a number, you might need it to be converted to a string. So like for instance, anything that's put inside of an input, you know, when you input information, on an application on a computer or something like that, in those fields, you put your name. It may ask you for your name, your telephone number. It may ask you for your age or something like that. Well, those are all converted to strings. Every input, it converts everything to a string. But now, once you get into your data system, like for instance, the age, you may not want it to be a string. You may want it to be a number. Or let's say if you are multiplying something, or if you're adding something, you want that expression value to be a number. So you may have to use the number conversion to convert that string number to a regular number. And it can only convert it if it's actually a number, not the word number or the word 3. It has to be the actual number 3. And the reason why it knows it's the number 3 is because of inside the binary number system, because it's assigned a value. So just like Boolean, it says explore how Boolean converts various non-Boolean values. It converts all these values right here. So I'm gonna open up a replit. Always encourage y'all let's see. I don't know. I am want to create an account. I guess. Oh well. I wonder why won't let me do that. Okay, let me log in. Here we go. All right, I know I had an account somewhere. All right, here we go. All right, so if I run all of these, they're all converted to a Boolean. True, all of these are converted to a Boolean. The true in the string is true. It converts this string, but remember now, notice the syntax here. It has to have the Boolean, and remember, it's a function. It has to have the parentheses. So don't forget those parentheses, because if I take this parenthesis off of here, you see it's giving me an error, right? And sometimes that's one of the mistakes you make when you're new to programming. You forget when you have like the 2 lowercase, you're going to add those in. You may forget to put the parenthesis around it. So it'll tell you an error like this is not a function or something like that. So just remember that methods and functions, they get parentheses. Any questions?
No questions.
All right, so now we've made it to the expression. Now we were talking about the expressions earlier. A Boolean expression is an expression that evaluates to either true or false. The Boolean expression. The equality operator, which is a double equal sign, compares. Remember these words, compare. When you're thinking about comparing something, you're going to either use the double equal signs or the triple equal signs. Most likely we use triple equal signs. Two values and returns true or false depending on whether the values are equal. So this is easy to see, right? You see console.log is 5 equal to 5. Well, you can see that's true, right? Is 5 equal to 6? That's false because 5 isn't equal to 6. That makes sense, right? Now, here it says in the first statement, the two operands, now these are called operands as well. 5 and 5 are operands. Remember that word, operands are equal. So the expression evaluates to true. In the second statement, 5 is not equal to 6, so we get false. We can also use double equal to see that true and the string true are not equal. Can anybody tell me why that's not equal? Why that's false?
Because one is a string and one is a Boolean.
Correct. Now look at it as if you are the compiler. What gives it away for you?
The quotations around the second true makes that one a string, and then the other one doesn't have that.
Correct. Now, that compiler can't see that. What the compiler sees is bytecode. Each one of those letters of console, that dot, that log, all of those letters, that parenthesis, it all has a value assigned to it. When it sees that true, it knows that, okay, this is a Boolean. And then it says there's two equal signs. It lets you know, okay, these are the two equal signs. And then the next thing it knows, it sees that string. It knows immediately that that's not equal. But let's go over here to see something else. Let's do this. Let me get rid of all of this real quick. Let me ask y'all this right here. If I do this expression right here, can y'all see this? What is that going to evaluate to? Is that going to evaluate to true or false?
False.
Yeah,
Why?
I agree.
You agree?
Yes.
All right. Now this is what we're going to learn the rule here. Let me run it. It's true. I asked the question. I know y'all.
So what makes it true?
Okay. Understand what a double equal is. A double equal is able to convert this right here because this is actually when the compiler sees this double equals, it knows that when it sees that quote, it knows it's a string, but that next character that it sees is that 5, which has a value in binary number to be 5. So because this is what we call a soft equal, we don't hardly use these in programming unless you know definitively that you want it to be a soft equal, because it may not return the result that you're looking for. Now, if I add that extra strict equal to it, the triple equal, you don't have triple equal in Java, only here in JavaScript. When I run it now it's false. This is where you learn the rules, how stuff works. This is why you want to pay attention to the code and understand what the output is going to be before you hit the button. So it's in your best interest to understand what the output is. So right here, that's something to add to your notes, right? When it's a double equal can convert a number. If it's a string, if it's two different data types, but it can't convert the word or the letters, because remember, this right here is a Boolean because it doesn't have the quotes. It knows that. This is a string. And all it sees is that T. That T has a value, that R has a value, that E has a value, that U has a value, that E has a value. This true has a value of 1, because in binary numbers, only 2 numbers, zeros and ones. 0 is false, 1 is true. So let's do this. Let's do this. Is it going to come back false or true? Is true equal to 1?
Yes.
Because you know the rule, right?
Yes.
I just told you, right? Yeah, because in binary numbers, 1 is true. That's how it reads in Bytecode. And I'm gonna go over binary numbers eventually. I'll go deep with that because it's important that I kind of understand it. But that makes sense, right? So
Makes sense.
if I do this, let me throw you for a loop again. What is that going to equate to? What is that going to give me back? Is that going to give me back true or false?
It'll return a true
Okay, why?
because 0 equals false.
Okay, there we
Or
go.
okay.
But what about this one? It's an empty string. Both of them empty strings. What is going to return on line 1 and what's going to return on line 2?
I don't know.
That's okay. Let's run it. Line 1 is false, but look at that. Line 2 is true. An empty string and false are equal. All right, let's do this. Let's go here. Remember this term right here. Let me see if that's the one I want. Nah, you know what? I want MDE. Let me see if I can find MDE. Here, let me do this. Okay, let me do this. Here we go. I want y'all to see this. And here, I'm gonna put this into the chat so y'all can have this link. There's the link to this. Now, truthy. Now remember truthy and falsy. Here, in JavaScript, a truthy value is a value that is considered true when encountered in a Boolean context. All values, see that keyword? Let me go ahead and let me underline that for you because I want y'all to understand and get the point. I want to get the point across here. All values are truthy unless they are defined as falsy. That is, all values are truthy except, here's the ones that are not truthy. False is not truthy. 0 is not truthy. -0 is not truthy. O of n, that's not on, that's O of n is not truthy. Empty string is not truthy. Null, undefined, and not a number. All of these are falsy. Did I spell it right? Yeah, falsy. These are all falsy right here. Everything else is truthy. Just these right here are falsy. So when I came over here and I knew that this was going to be truthy right here. I knew this was going to be true because false is equal to an empty string. But now that's only with a double equals you can do that to. If I do that with the triple equals, they're both going to be false because these are two totally different data types. Strictly equals always deals with the data types. It compares the data types. If the data types don't match, if you use 3 equal signs, if they don't match, it's going to be false. All right, that makes sense. Any questions?
No.
Now, here's a chart on comparison operators. I want y'all to go ahead and read those on your own time. And then we're going to do the check your understanding. So we just went over this part, 5.1. So let's go over into 5.2. We're going to see how far can we get before 7 o'clock. So here we go. Equality. Now, we were just talking about the difference between double equals and triple equals. So now we're going to sit down here and explain a little bit more, okay? So in this section, Booleans, we learn about the comparison operators, double equal and question mark equal, which means not. The question mark is it's called not or a bang, B-A-N-G, bang. So when you see this right here, that means not. So when we get into conditionals, this changes the Boolean value. So and we'll talk about that more when we get in conditional because I don't want to confuse it just yet. But just remember, this means not equal. Which test, now here's another key word, test. Whenever we are comparing something, we're testing whether two values are equal or not equal, respectively. However, there are some quirks with using the double equal operator, which occurs when we use double equals to compare different data types. Now, we were just talking about this. So right here, we saw this in action right here. Even 0 is equal to empty string because that's falsy, remember? So it's important that you pay attention, especially right now in your career. As you're learning, you have to pay attention to what the code is saying to you. Because you got to pick up on, if you can pick up on the little small details, the little small nuances, it's going to help you to become a better programmer. As a matter of fact, it's going to teach you how to debug your problems because you first will ask yourself, is this following the principle and the rule of the programming language? When you start getting errors, you can go back and look at your code and say, okay, that doesn't follow the rule and the principle. This is going to be a problem. I need to address that. I need to fix that. So it's just like in life, really. When you know there's a problem, you fix it, right? In order to properly make a comparison. Yeah, you got a question?
No.
Okay. In order to properly make a comparison, the two operands must be the same type. If the two operands double equal are of different data type, JavaScript will explicitly convert the operands so that the values are the same data type before comparing the two. So in JavaScript, it does some converting, right? Of the operands. Remember, these are the operands. Anything that has a comparison in it is an operand. So remember that. That's another one of those words I want you to remember. And then it says here, for this reason, double operator is often said to measure loose equality. Remember that word. Type conversion with double equals are carried out according to the complex set of rules. All right. Always click on these links when you get them so you can see what it's talking about. So here we are in the equality comparison and sameness. This is MDN Web Docs. JavaScript provides 3 different value comparison operators. Now, this is important that we came here because you probably don't even know what this object dot is, right? You never probably seen that before.
No.
So here, the triple equal is strict equality, which we say triple equals. Loosely equal is double equality, and then we have this object is. I always like to click on stuff. What does that mean? Object is, which is a method, determines whether 2 values are the same value. So here's the syntax. Object dot is value 1, value 2. The first value to compare, the second value to compare. Return value, a Boolean indicating whether or not the 2 arguments are the same value. All right, let's do this. You know, we got to always play around with it, right? So, and let's put this inside of a console.log. Now let's give it a value. Let's give it 5 and 7. Let's get rid of those because we don't need those to confuse us. Let's run it. False. 5 is not equal to 7. True. 5 is equal to 7. So you can use this right here to compare. So now you got another tool in your tool chest that maybe you didn't know, right? So it's important to take your time to go through the lessons. Click on these little things like this, because all it's going to do is help you see something that you wouldn't have saw on your own. And as a new developer, when people are going over this curriculum, they gloss over this information because they don't know. They didn't know it was, they're just trying, especially if you're going through Launch Code, you're just trying to get through the chapter. You're not really going through studying it. And that's what's going to help you is pick up on a lot of this stuff, is putting that extra time to get the understanding. So while many of these conversions may make some sense, others do not. For example, number, and this is the conversion number function, 7 returns 7. So it makes sense that 7 softly equals to 7 returns true. However, the following example leaves us scratching our heads. Right here, this is confusing if you didn't know the rule, but y'all know the rules now, right?
Right.
You know number 3 is going to be false because that 0 is inside of a string. And so is 0 is it softly equal to the empty string? You would think, well, wait a minute. Doesn't that see 0 right there? How come that's false? How come that 0 is not equal to that empty string? Because, again, this quote throws it off. The value of that quote throws it off right there, because now this is nothing there. This actually is occupying something. And so let's read on. The double operator is non-transitive. We think of equality as being transitive. For example, if A and B are equal, B and C are equal as well, right? Then A and C are also equal. So if A and B is equal and B and C is equal, you would think A and C is equal. Correct? That makes sense, right? That's transitive. But the softly equal operator is non-transitive. So it means, however, the example above demonstrates that that is not the case for double equal operator. Since double equals does not follow rules that we typically associate with equality, unexpected results may occur if double equal is used in a program. Thankfully, JavaScript provided another operator that returns more predictable results. So we understand A and B. If they're equal and B and C is equal, we would think A and C is equal, but we know that's not true. Can you explain to me why that's not true in programming? How come A is not equal to C? All
So oh,
Go-
sorry.
now you go ahead.
Oh, well, so in that statement says if A and B are equal and B and C are equal, then A and C are also equal.
That's
So
trans,
uh-huh.
but it's non-transitive. So in computers and in our computer programming, that may not be true. All right. So you want to do an example so we can see it. Okay. All right. So here we have this object here. Matter of fact, let's do this. Let's create a variable. I'll let num. Matter of fact, let's let A. Let's let A equal 1. Let's make sure I do this right. So A equals 1, right? So we got this. So let B, yep, let B assign to A. So what is B then? If I call B, what is B going to be? Console log B. What the result I'm going to get?
Would it be 1?
Okay. Correct. It's 1, right?
Mhm.
So that makes sense, right? So let's C
Right.
equal B. And now let's see what. So C should be 1, right?
Mm-hmm. Yeah.
Make sure I do this right because I don't want to confuse myself. So
Mhm.
now, if A is 1, B is A, C is B, the next thing I want to do is A, C, right?
Mhm.
I get an error. And the reason why I get the error is because I got that letter in there. Let me get rid of that. Okay. Still 1. That makes
Mhm.
sense. Maybe I'm wrong.
Mhm.
I think I'm not though, but I can't remember. I can't figure out how do I do that. But anyway, that's one of those going down the rabbit holes again. So maybe I'm all right. So now we get into the strict equality with strictly equal. Now the operator strictly equal compares two operands without converting the data types. In other words, if A and B are of different data types, say A is a string and B is a number, then A strictly equal to B will always be false. That makes sense because these are strictly equal compares data types. They have to match. For this reason, go ahead, you got a question?
No, sorry.
So for this reason, the triple equal operator is often said to measure strict equality. You're going to use this more in your programming. You're rarely going to use double equals, just to let y'all know that. Just as equality operators, double equal has the inequality operator not equal. There is also a strict inequality operator, the not strictly equal. So don't get confused with that. So an exclamation point is a not or bang. If you hear, you're going to hear that other word too in your career. So not strictly equal the Boolean expression, A is not strictly equal to B, which will return true. So this is what I was talking about earlier with the not. It changes the meaning of something, right?
Mhm.
So if we come back over here, and so let's go up here and get rid of this. So if A, well, we got to create a data type. Let's create some data types here. So let A sign it a string, right? Let's sign it a string. So we just signed it that string, and then B, we're going to assign it a number, right? Now, A strictly equal to B. We know that's going to be false, right?
Right.
Two different data types. But if I did this, I put that not in front of it. Now what it's saying, A not equal to B, that makes it true. Remember, this gets confusing right here. I ain't gonna lie to you, I gotta really think when I'm using these. Because this is really dealing with your condition and dealing with state. And this is gonna make more sense when we start dealing with state. So for instance, if I go in here and I create a Boolean, so let on equal false. So I'm gonna say let on equal false. So I'm setting that to a Boolean. So down here, let's say if I did a condition. So if not on, so I will put the not on, because remember, it already has false in there. And I put the not in front of on, it makes it true. So now on would be true instead of false. Or vice versa. If I turn this to true and then I put it to not, it'll turn it to false. Because remember, and we'll talk about this when we get in conditions, anything inside of the parenthesis in an if conditional is going to be true unless you state it to be false. That's when we read that in our truthy statement in MDN. Make sure you go over that documentation and make sure you fully understand that. So here we have, it says A not equal to B returns true. When the two operands are different types, or if they are of the same type and have different values. If you throw that not in front of it, it turns it into the opposite. So if they were false to begin with, if A, which is a string, and B is a number, if it was strictly equal, that would be false because they're two different data types. But as soon as I put that not in front of that equal, so if I say not equal, it just flips it. It's going to say it's true because you're basically stating the obvious. They're not equal. So that's true. They're not equal, right? So that makes sense. A is not equal to B because A is a string, B is a number. So that makes sense. But that's why when the output is true, it's saying that what you're saying, your statement is true. Like I said, that could get kind of confusing, and it kind of sounds confusing when you talk about it too. So check your understanding, and we're going to stop there because I want y'all to go over this. Take your time. On Saturday, we'll go over the studio.
Okay.
We'll record the studio. So I'm going to stop that right there. Let me stop my recording.